Hey everyone, hope you're doing well. And I have decided to make a flat fill algorithm in Matlab. Uh, though there is an image fill-in function in Matlab, for some better handling I have decided to make my own. And so let us start us off. Now we should load our map, which we will be filling. I have one in my files, and so we shall read that one from a picture. This is how our map look numerically, and this is how it looks like. You can see the colors corresponding with the numbers, and we will be filling an area of the map using a completely different color, and by that I mean value. So how should we approach this? We will first need to set the point from which we will be filling, and so that will be our starting X position. In our case we shall start from 4th position in X-axis and 4th position Y-axis, which is the center of the picture. So let's X start and Y start as before, and we shall also need the value of the color that we will be changing into. We will be filling the area with some different color that may not even be on the picture yet. So color fill will be, I'll say 9 for this example, and we should be good to go. Our image will be function will be created in flat fill function, and we will send it our map, start position, both X and Y, as well as the filling color. Now we shall make our function our flat fill function, just like so. Flat fill will be filling up an area in a certain place, so we will need the value of the color which is on the starting position. So let's take it, we shall save it into color search. We'll be searching for this value, and that's on the map on the position X and Y which we sent it. Right, now we shall create our initial image, which will be exactly the same as map. I will not be changing the original map, that will be data given to me, and so I will only be changing the image, not the original one. So this image, my first step will be that on its starting position I will fill it with the color I'm filling it with. That will happen in the center. Now I'm gonna have to go in the 4 neighborhood, which is left, up, right and down. And how do I do it? I shall make a depth first searching algorithm, my DFS. I will keep it in my image, yeah, just like this, my image variable, where I shall have my new map. To this DFS function I will send my map. Come on. Then the image itself as well. This is my start position, X and Y, the color I'm looking for, and the color I'm filling it with. Good. However, we shall be moving in 4 directions, so there will be differences in the X and Y position for each movement. So I shall also need these differences in X-axis and differences in Y-axis. What are these differences? If I move left, my X will change -1. If I move up, it does not changes. Right, 1 is added, and down, nothing happens to X. Now as for Y's, when I go left, I need to keep the same order. Y does not changes. Going up, -1. Right does not changes, and down adds 1. And I will send my DFS these differences as well. Okay, there we go. So we're good to go to create our function to make the depth first searching. Will be of course the same as this one. Now, how do we do this? So, because we are moving in all these directions, we will need a new positions for our X and Y, which will be our start position of X, and we shall add exactly the difference, but since it is an array, just like this, since it is an array, we will need a position of the element in that array, and we shall come to that soon. We will do this for Y as well. Okay, now how to do this part? We will be going in 4 directions, and because we have 4 elements in our Y differences and the X differences, we can make a for cycle. Step of 1, and it will be going as far as the length of any of the differences are. Yes, in this example it's 4 directions, so it will repeat 4 times, and for each cycle we shall take our new position. Okay, now it's time to ask questions. That is the favorite part of this algorithm. So what we need to know is if our new position is still on the map. So our x new must be bigger than 0. Also, our x new must be less or equal than the size of our map on first position, which is the size of x-axis. Also, we will need our y new to be also bigger than 0, so we will be on a map. And well, I'm gonna copy this one. Our y new must also be lower or equal to size of map in y-axis, so map 2. We will be asking further. Now, in order to fill our new image with the new color, we are looking at the map, and its value must be on the new position the same as the one we are searching for. So what I'm gonna do is I'm gonna look at the map on the new position, and if that is the color I'm searching, that's what I want. And also if my image on this same position is still not the color I'm filling it with, and all these if all these are true, then that is when I want to do the filling. So my image on the position will be the filling color, and I will send the image back recursively to this function, the depth first searching algorithm, but not with the starting X, but with my new X and as well as Y. So when I have all this done, my new image should be looking filled with new color from the starting position. So once we have this, we shall close our skin and we will set the function dfs to be our image, and once we run it, we can see that the area has been filled with new numbers. Now we can make this more interesting. Instead of just horizontally and vertically, we can make our flat fill go diagonally as well. So I'm gonna make a little change over here. I will change my X and Y differences. Because I'm starting on left going clockwise, I will start with my X position lowered by 1, then it will be lowered once again. Going clockwise, we're at 0, then 1 is added 3 times, then we're going back to 0, and we will return to the corner -1. These 8 new elements will be my X differences, and as for my Y differences, we will start with 0, going -1 3 times, then we will return back to 0, and we'll be going 1 extra 3 times. These will be the 8 elements for my Y difference. And if I run this, I can see that my flat fill fills from the center diagonally as well. So this is how my flat fill algorithm works. I hope you could enjoy the video, perhaps learn something new, and I hope to see you sometime again as well.